Today we will talk about Netless, and let's start. I think I will share my screen and I will talk about some features and will show some actions in parallel. So all of you make familiar with share and make familiar with this application. Share my screen. Yes, yes. Okay. So I think most of you already understand the main concept behind the Netless. It's an internet scanner, and the general goal is to scan the internet from cycle to cycle, another and another time. We store the data in our databases. And this is our core purpose. We have some additional collections. We have domain name collection here. We have AP whois that collection here. We have domain whois. We will discuss all this later. But the general is the responses data collection. Internet scan results are stored here. Each result is stored as a JSON document. I believe most of you know what is JSON. It's a format of the documents, and when you search something in Netless, for example, let's search, for example, host 8888, for example. You actually searching for JSON documents in our database, and each of those documents should have this value in this field. It's pretty simple. So if we open the document, every search result represented as such document. If we open it, and if we look through the fields that are stored in the document, we will find a host field that have value 8888 here. So I think it's pretty easy. Let's move on. Other collections, pretty similar. The only difference is mapping. Here is the mapping. The mapping is fields in the documents. So when we search for responses, you can see that all these documents have similar fields. For example, every document has a geo field, every document has AP field, URI, and so on. And all those fields stored here in the mapping. It's for make it easy to search, make it easy to you to search. You just clicking on any field you want to search, for example, protocol, and it's already here. You type, for example, HTTP, and searching. That's all. Let's quickly walk through other collections. Here we have DNS, domain name system. It's for domain records. For example, let's search for Netless domain, netless.io. As you can see, the mapping is different here. because this is another data collections with another types of data. And here you can see A records. It's IP addresses for this domain. You can see our name servers. You can see our mail server, some TXT records, and IPv6 address if presented. We don't use IPv6 for because this is just dash here. Let's search, for example, subdomains of Netless. You can see 4 other records up Netless IO that is we are seeing right now, pay Netless IO, and so on. Each of those records are ELSA JSON document. AP whose data is used for identification of owner or of AP range, or who uses this range. For example, if we search for famous Google's DNS server, we will see that this AP address included in this range, whose data is presented for the ranges, not for single AP addresses, but for the networks, subnets. We can see that this AP address is included in this range, size of 255 hosts. And we can see organization here. It means that Google owns this, manages this range. And we can switch to contacts. We can see contacts here, and we can see row response that that collected by our scanners from whose server. We just parse this data and put it to JSON document in form of parsed fields. So all those fields are available here in mapping. You can, for example, search for I don't know, let's search for example, net country. Let's use net country, for example. We have 42 network ranges related to Vatican City. You can scroll through them. Let's move on to domain whos. Pretty the same, but for domain names. For example, let's look for domain Facebook, for example. This information provided by Facebook when the domain was registered. Here we have contact. Here we have organization name. The main difference is this data collection related to domain names. And the last one is certificates. It's a storage for all the certificates from SSL and TLS protocols Netless have grabbed from scans or from certificate transparency log and so on, different places. The usage is the same. You can select any field you want to search and filter our database to find some certificates. Let's walk through most interesting fields in mapping. Of course, we will talk mostly about responsive search because this is the core of Netless. Let's start with addressing fields. The most commonly used AP and I think host. You have to understand a small difference between those fields. Both fields are mandatory. Both fields presented in every response, but AP address, AP field, it contains address from which the response was received, and the host is the AP address or domain name used in actual request. So when I type AP 8888, I will get 2000 responses from every server that points to this AP address as a record. And if I type host, I will get only responses that use this AP address when we send request. This is the difference. And host can contain domain. AP, of course, can't contain domain name. That's it. What else? We have three different fields for protocols. We have protocol field, we have prot 7, and we have prot 4. The difference is in level of requests. When we talk about prot 7 and prot 4, we are talking about OSI model, open OSI, Open System Interaction Model, famous interaction model that describes 7 levels of interaction between open internet systems. And prot 4 means transport layer, and prot 7 is about application layer. So if you want to for example, filter out only UDP protocol or TCP protocol, it's transport layer protocols. You can use prot 4 and, for example, UDP. You will get only responses received using UDP transport layer protocol, and you can use TCP, vice versa. Prot 7. Prot 7 is an application level, so you can use, for example, HTTP for Prot 7. And this is a backbone of the internet. It's a very often used protocol. There are a lot of responses for this protocol. The difference between Prot 7 and protocol is in security layer. Prot 7 could be only HTTP. Protocol could be HTTP or HTTPS. So if you want to scope your search, for example, for only security layered, security version, safe version of protocol, for example, you want to filter out all unsecured HTTP connections, you can use protocol field for this. And here we have HTTPS responses. Again, HTTP, Prot 7 is for protocol itself. When you use HTTP with Prot 7, you're searching for every HTTP response, secure one and unsecure one. And if you use protocol, you have to specify a concrete version. For example, HTTPS, FTPS, or FTP without S. This is the difference. What else? We have some information fields. We have, I think, most interesting one, tags and CVs. CVs about vulnerabilities and tags about technologies. Um, mm, Yes, I think I should describe the concept of passive scanning. Netless is a passive scanner, and there are two types of scanners, passive and active ones. Active scanners is usually um, um, when, for example, active scanner searching for vulnerability, it's usually make a safe exploitation of some vulnerability to understand that this vulnerability is actually exists on this host or in this environment. And when we're talking about passive scanning, we are talking about only suggestions. We don't know actually if vulnerability exists when we are talking about passive scans. It's just a suggestion. Uh, and the same about identifying any technology. Netless is a passive scanner. And when we are talking how Netless identifies some technologies, we just searching through the response. We let's for example see for any Apache response. How we understand that this exact response is from the Apache web server. We just found this header and we suggest that this server is Apache server. And if we found here, for example, Nginx, we will tag it as Nginx. We don't actually check if this Apache or if this Nginx server, we don't know. It's just our suggestions based on the content of the response. For example, for, I don't know, WordPress, WordPress, the famous CMS. Let's search for it. We don't have a header, but if we search for this response, WordPress, yes, we have it here in the comment. We have it here in the content section, WordPress 6.8. This is version. We still suggest that this response is from the WordPress CMS based on the content of the response. So the passive scanning has some pros and have some cons. The pros are it's very fast and it's very safe. It's fast because we already have all the data we need, only one request and only one response, and we analyze it and we get all the data to make our decision, to make our suggestion. And it's safe because we don't do anything. We don't do any actions beyond what the system is designed for. Only one simple request for the main page of this web server. That's all. Of course, the cons are in false positives. We don't actually check if this is WordPress. We don't do any sophisticated requests. We don't do any fuzzing, I don't know, any other techniques to understand this is exactly WordPress. In the same way, Netless identifies vulnerabilities. If you search, for example, any document with any CV, if you see here, you will find, for example, this one. This CV is added here because we think that this is OpenSSH of this exact version, 8.9.9 P1. And they know that this version is vulnerable, is affected by this exact vulnerability. It's our suggestion. Maybe this exact server is not vulnerable. Maybe administrator is already patched this, or maybe it's configured in some way that this vulnerability is not actionable in this exact environment. But based on the version of software, we think that it could be vulnerable, it can be vulnerable for this vulnerability. That's it. If you see to the mapping, you will see you can search using base score, you can search using description, has it exploit publicly available or not, name and severity. About text, we have about 1,000 different texts here or here. You can see all those texts here in the mapping also. Let's continue. Let's continue to top fields for threat hunting. I have 5 fields that I think interest for threat hunting. First of all, of course, it's a port field. When we are talking about advisories, when we are talking about command and control servers, it's usually unstandard ports. And of course, you can use this field, for example, like this, to search any, to filter out documents using the port field to search for any particular port responses. What else? We have a very interesting JARM field. JARM is a fingerprinting technique. It's based on SSL. It's based on how host answers to how host configured to exactly establish SSL connections. You can read more. It's a protocol by Salesforce. They have very good article on this protocol, and you can read about it. The main idea is if you use custom SSL TLS layer, you will have very unique JARM fingerprint. If you use something common, for example, you use, I don't know, Windows operation system and default installation of EAS on it, the JARM will be very common. But if you use something unique, for example, if you wrote a program or maybe command and control program, and you use very unique configuration of security layer that is pretty common in advisory infrastructure, the germ will be unique for this exact implementation or for this exact environment. What else? Certificate field are used very common to identify different advisories, especially if they use, for example, self-signed certificates for vanilla installations. You can use issuer then, or subject. And subject then, and subject. It's a pretty common. Subject is parsed version of subject DN field. I know, for example, I know a few tasks in our challenge uses these fields to identify some vulnerability infrastructure. Row TCP, we have in protocol section, we have row TCP protocol. That is actually also can be useful. When Netless finds something that he can't parse for any reason, it could be not good HTTP, it could be FTP or any other protocol that we can't exactly parse and store with our parsers. It stores as row TCP. So sometimes it could be very useful to search in this protocol using this field. You have full banner, and you have fingerprint of this banner hash, cryptographic hash. What else? And of course, HTTP. HTTP protocol is very commonly used. There are many subfields in this field to search. For example, you can use title, you can use status code, you can use headers, different headers. Actually, we have two header fields. We have headers here and we have unknown headers. You have to understand difference. Here we store 1,000 most commonly used headers. And you can search here, for example, content type, JSON. Here we can see content type, application JSON headers. And here in unknown headers, we have all other headers in form of key value pairs. So when we search for unknown headers, we should search in a little different way. HTTP, unknown headers. Here we have only two fields, key and value. So you should specify key and put the value here. For example, custom header. Let's remove this. This is to search servers, to search responses that return header named custom header. And if you want to specify value, you should specify it like this: and value, and put some value here. Actually, we have about 1,000 response with header name, custom header. Yes, here it is. Headers, unknown headers, favicons. You can search using favicons. It's pretty useful. Sometimes let's search for any resource, for example, I don't know, x.com. Yes. You can search by exact match, or you can use average hash. Average hash is about closest images, closest to this one, with little differences. For example, little different encoding or little different color, maybe not this exact black, or little gray, maybe. So average hash is very useful. Let's search, for example, for domains with such favicon. Average hash called perceptual hash. HTTP favicon perceptual hash field. I know that sometimes command and control servers have favicon to search in. What else? Of course, it's a title and a body fields. Let's search for title. I don't know. For example, Google. I don't know, any name. It's title names. I'm sorry, web page names, web page titles. You can find it here. Here we have HTTP protocol. We have headers, we have status code, favicon, and description, and somewhere it should be a title. And of course, body. Usually, web page body contains everything to identify some technology or to identify any software. Let's search for something in body. Search in body field is case insensitive, and there is another restriction. You can't search for tags, or you can search for exact symbols like this one or like this one. All those fields are cutted. We store only information. This is because of database limitations. We can't just store and process such huge amounts of data, and we can't give access to exact search for such large fields. But full text search is okay. It works pretty good. And if you want to search any word or any combination of words, for example, WordPress, and for example, use WordPress, you can just put them one by one. I think that's all about fields. Let's say a few words about syntax. We have a very, very simple query language. As you saw already, when you query something, you put you put field, column, and value after it. And you can combine different fields with AND, with OR, logical AND, logical OR, and logical NOT. For example, AP111 and NOT port 80. It means give me all the responses from this exact IP address, except those one from port 80. What else? When we talk about numbers, you can use less. You can use those operators. Let's search for documents with port number less than 100. And port less than 100. Yeah, that's it. And you can use ranges for numbers, for IP addresses. You can use ranges. For example, you can use ranges from 20 to 25. It means 20, 21, 22, 23, 24, and 25. There are no such answers. Let's put it to at least 80. That's it. If you want to learn more about query language, or if you want to find examples, you can read through the documentation. Here's the question mark, and here we have a good article, Search Basics, and here we have very much examples, how to search using geolocation, how to search using titles, and so on. I can't see chat right now, or I can. Yes, I can. Does anyone have questions about searching? This is the time to to ask. This is a good time to ask. Yes, we have one question. Could I find domains by org name? Reverse who is domains by org name. Sure, you can use any field available in mapping to search. For example, if you want to search domains registered to, for example, I don't know, Facebook, we have here this sample. You can use registered organization, and you just put Meta or Meta platforms here. And in this manner, you will get about 70,000 of domains registered to Meta platforms. Or you can use any other fields. For example, I like to search using emails. It's much more it works better in some in some cases. For example, we have this sample registered email. Those are domains with this email in contacts. We have another question in Discord about Gofish CSS, but I'm not quite understand this question. Gofish CSS. Create search query using Gofish CSS, but I don't quite understand it. Let's search for Gofish CSS. I think if we are searching for CSS, we should search in the body section, because this is the place where CSS files are mounted. And let's search for HTTP body Gofish CSS. I think it's something that they searching for. Maybe we just give a good hint. I can hint you one more time. Here I can see a favicon you can use for searching. This is exact match search. You can use perceptor hash to another to build another search query. I hope I have answered. Okay, let's move on. Thank you, amazing. Thank you. Okay, let's move on. Let's talk about another tools we have here on the Netlast platform. We have two other tools. We have Discovery tool, Attack Surface Discovery. It's for finding connections. Actually, we just talked about reverse whois domains and how they relate to organization. Let's try to make the same using this tool. I think it's pretty interesting. Let's put facebook.com here. And oh, it's so small. It will take some time, but this tool is actually for searching such connections, so searching such links. For example, here we have different search directions, and we can put A records to our map. We can put subdomains, and let's search using organization. We can add organization, and we can search using this organization, and we will find other group of domains, and we can know. Oh. It's something with my pricing plan. I think it's just too much to add to the map. I will search using any different direction. Let's search using this one. We have name servers here. Name servers that are responsible for Facebook domain. And we can search what else, what other domains those name servers responsible for. And here we have 11,000 domains, much more, 23,000. I think Facebook is a very large organization, but I think you already understand the basic principle. it's for finding connections. And another useful tool is scanner. No, I don't have to save it. Is a scanner. It's a private scanner. So when we searching something in the responsive search, we use publicly available data. This is the data gathered by netless scanners. And if you want to scan something for your own, you can use network. You can use netless private scanner. You can put any IP address, any domain name, or any network here. For example, I will put here this network as an example. I will turn on automatic updates. And while the scanning is in the process, I will describe you the difference between public data and private scans. When netless scans the internet for publicly available data, we use only 150 most commonly used ports. It's the list is available in the documentation. It's only 150 most commonly used ports. And we can't make it larger because of the time. Right now, we scan the internet once about 3 weeks. Every new port means new responses, means this time will increase. And we want to have fresh data, actual relevant data. So if you want to scan something more precisely, for example, you want to scan any IP address with larger amount of ports, you can use netless private scanner. When you use this scanner, you scan about 2,100 and close to 2,000 ports. 2,000 most commonly used ports. So this scanner, it creates a private index, and you can search this index as you search any other data in netless. Here you have button search, and it moves us to responses search tool, and here under index selection, you can actually choose what indice you want to search. We have a few indices, historical indices, publicly available, and this is my private indices. It's the same list as you can see here. What else? The last thing is our API. This application and all the data you see here is available via API. All the netless functions available via API. We have three general. I will show you here. We have three general ways to access API. How to get API key. You can find it here in the profile section. And we have three tools. You can access API directly. You can use our SDK, pip install netless, and you can use CLI tool, command line tool. If you prefer, for example, bash scripting, here how it works. Just let's find any It's a Python example. It's direct API access. Here you can see netless CLI tool. Netless host, put your API key here, format, choose the format, or this key is optional, and you will get the same data if you search it via the web app. Here how to search using different data collections, responses collection, domain, AP whois, and so on. And of course, you can use a Python. You can make queries via your code. You can include. Actually, we have some integrations already, but you can make your own integration, or you can add netless into your own scripts. Or you can use something that is already developed. We have a list of already made integrations. I think it's here. We have Chrome and Firefox plugin. We have SubFinder, very popular for SubFinder integration. We have Harvester integration, AMAS, and some others, not so famous. So I think that's it. I think I told everything I wanted. If you have some other questions, please ask. Let's wait a little.
Yeah, we have a question. Is it possible to change scan parameters? For example, instead of SYN, full TCP or increase timeout or something like that? Question from Alexander.
It's a good feature request. I'm sorry, but no, not right now. This scanner is pre-configured. Actually, it's the same scanners we use when we scan the whole internet, but only with the larger amount of ports. That's it.
Okay, one more. I found that the past index is not working. I get an error saying that server timeout.
Yes, it could be. It could be. If you open this index selection window, you will see that we store some indices in the fast access memory, and some indices are moved to slow access memory. And I just recommend to make it one more time, one or two more times. There is a cache in the database, and sometimes it's just 5 more times. It means you use very very rough query, very hard query to process. Try to make your query not so remove, for example, asterisks if you use them. Don't use regular expressions and so on. Sometimes it's very hard to get results from archived indices.
So make it easy, and it will work.
It should work.
Maybe I have one question about the custom scans. Like how long does it take approximately? Like, is it a long process or?
It depends. It depends on number of targets. Mine is already already almost done. It was one small subnetwork. It's pretty fast. It takes about 5 to 10 minutes to scan not very large network, for example, 24/24 network. It's finalizing right now.
So yeah, okay, it depends on the volume of the network and the
Yes.
parameters. Okay.
Yes.
Okay. Okay, one more question from Kishan. I've had a question about Havoc C2 analyzed Git repo. So
yes, it's a good
okay.
question.
Yeah, we will.
I think it's a small bug in the card. I think there was a question about. I have to give some background about how to search for C2 named Havoc. And the search was made using header, using HTTP header, but CTF platform doesn't get this search query as a good search query. There will be one more webinar on Monday, and Yuri will talk about how to submit. I think Elsa will talk about how to submit answers, and you can answer him because he's the author of those tasks.
Yeah, for sure. You can directly ask him on 5th of May, and yeah, everything will be fixed. So no worries. Just keep going. There's a lot of other tasks on the platform, so no, keep going, and we will fix it. Yeah. So thanks a lot again for this insightful lecture. I think all these examples could be directly applicable to the challenge tasks. The recording will be available on the YouTube. So if you have any question, don't hesitate to ask in the Discord channel again. Okay, I think we will wrap up for today. Thanks a lot for your time.
I just want to, I'm sorry, Anna, I just want to say one more time, thank you all guys. This is our first challenge, and this is, it's quite a lot of fun for us too. Thank you very much for participation, and thank you very much for your interest to the platform and to the event.
That's great. Kishan wrote that he learned a lot. That's great. That's the main purpose of the challenge. So we're sharing knowledge. We are we learning new things, new skills. So that's the main purpose. That's great that you found it useful. So again, yeah, thank you, and see you on 5th of Monday. So goodbye for now, and
Thanks. Bye bye.
see you.